All right, let's get on with it then. We started talking at the very end last time about Condorcet's method. That's what I want to talk about some more today. Condorcet's method. This is the one based on making pairs of the candidates and comparing them in pairs, sort of like one-on-one matchup. So I will remind us of the how it works. You compare everybody in pairs, like if it was A, B, C, and D. First you look at just A versus B. How would they have gone if it was just A and B? And then you look at what if it was just A and C? How would it have gone down in that sense? All right, you compare everybody in pairs, and you find a candidate who would win all of their pairwise matchups. And there's a name for that. That candidate is called the Condorcet winner. And then I will say choose that one to win the election. All right? You analyze all the various ways you could pair them up. This may take you a few minutes to do. You got to work out some details. And then you find one who would win all of their pairwise matchups, and you choose them to be the winner of the election. That's how the Condorcet method works. All right? It's quite different from ranked choice and certainly different from plurality. It'll take you a little bit longer to do all of the necessary computations. It's not really hard. There's just kind of a lot of little things to check. I thought, let's try just an example. Let's do the example of that big election that I had on the handout. I'll just copy it down here. There were 37 voters total, remember? This is our 37 voter handout election. This is on the first day. I'll just write down the chart that appears on the bottom of that handout. 14 people said A, B, C, D. 10 people said C, B, D, A. 8 people said D, C, B, A. 4 said B, D, C, A. And 1 person said C, D, B, A. All right. And we've already looked at this using the plurality. With the plurality, A is the winner. We also looked at it with the ranked choice. I believe, did anyone have the handout? I don't remember. I think D was the winner with the ranked choice. What about with Condorcet's method? All right, we got to compare them in all possible pairs. So pairwise. And there's actually several different ways you could choose pairs. I could go A versus B. I could go A versus C. A versus D, and then there's some other ones too. I'm going to try, just before we get down to work on this, I'm going to try to write down all the possible pairings. So I just said I could do A versus B, leave some space there because I'm going to fill in the details over here of what would happen if it was just A versus B. And then I'm also going to do A versus C. I'm also going to do A versus D. Those are all the possible pairings which involve A. You want to be somewhat systematic in writing down all of these pairs just to make sure that you get them all. These are all the ones which involve B. These are all the ones which involve A. All right. Now I can write down any remaining which involve B. I've already got B versus A, so I can next go to B versus C. Right. I don't do B versus B, of course. And then B versus D. All right. Now I have listed all of the pairs which involve B. I got A versus B first, and then I just wrote B and C, B and D. Are there any left? Any more pairs that I haven't mentioned yet? Yeah, what else? C. Yeah, I can do C and D, and then actually that's it, right? So I write down all the ones involving A. There are 3 of those. Any more involving B, there's 2 of those. And then any more involving C, there's just 1 of those. And then D is already taken care of in amongst all of those other ones. So lastly, I got to do C versus D. All right? Just make sure you get them all. So can I say, just as a rule of thumb, I suppose you could memorize this if you want to. With 4 candidates, there's 6 possible pairings. I mean, you don't have to memorize that, but you will find yourself wondering, am I sure I got them all? Well, if you can remember. With 4 different candidates, there are 6 possible ways you can pair them up. That's how you know if you got them all. Anyway, let's actually try and sort of do the math here. A versus B. What I got to do is look at this chart here. This is, I guess, a little like the rounds in ranked choice, but I'm going to look at the chart, ignore all the C's and the D's, only looking at the A's and the B's, and decide who would have won in that matchup. If I ignore all the C's and the D's, only looking at the A's and the B's. So I will just count up. I think it's easiest to just count up in this chart how many voters put A above B versus how many voters put B above A. That's really what I'm looking for here. Do they like A better or B better? So as I look in this chart here, I see these 14 people put A on top, and actually nobody else did. Everybody else put the B on top of the A. All right, so 14, I'm going to say A gets 14, whereas B gets everybody else. Everybody else likes B better than A. And that would be, these add up to, so it's 10 people here, plus another 8, plus another 4, plus another 1. That's 8, 18, 23, right? I said before, there were 37 voters total, so these numbers, which I'm writing here, they better add up to 37, or else you messed it up somehow. All right? So what this means is 14 people like A better than B, whereas 23 people like B better than A. And so who's the winner in that particular matchup? Maybe I'll just like circle the B. The B is the winner in that particular matchup. And then we got to do this for all of the other ones. All right? This, like I said, this is not really hard. It might take you a few minutes to work out all the details, but you just got to do it. All right? Any questions about that one? Let's see if we can do A versus C. Again, you look up at the chart here. How many people liked A better than C versus how many people liked C better than A? And actually, I think it's much the same results here. The first column likes A better than C, but in all other columns, A is on the bottom. So all the other people like C better than A. So the numbers here, again, are A gets 14, C gets 23, right? 14 people liked A better than C. Everybody else, that is 23 people liked C better than A. And so the winner in that matchup is C, right? 23 beats 14. And then, actually, maybe you can see how this is going. As far as A is concerned, the same numbers come up in A versus D, because there's 14 people like A above D, but everybody else puts D above A. It's not terribly interesting so far, but this is just a fluke of this particular example. You usually don't get the same numbers every time. But in A versus D, A gets 14 votes, whereas D gets 23. And so D is the winner in this matchup. All right, maybe I'm gonna put my guys all up here so that I don't have to scroll. All right. These ones are going to be a little bit more interesting. When we compare B versus C, move them up just a little more. All right, B versus C. You got to look carefully here in each column and count up how many people like B better than C versus how many people like C better than B. I see 2 columns that have B above C. There's this one, these 14 people, and also this one with 4 people. The B is on top of the C. In all other cases, the C is on top of the B, right? And so, what's the number for B versus D? C. What's the number for B here? What'd you say? 18, they said. Yeah, that's these 14 people plus these 4, right? 14 and 4 is 18. Okay. 18. Versus how many people have C above B? That's these ones, that's 10. Plus these ones, that's 8, plus these ones, which is 1. So 10 and 8 and 1 is 19. So C wins this matchup, 18 to 19. And so on. I hope everybody's got the idea here. You just gotta sort of see it through. B versus D. I'll let you all think about this one. What do you think? How many points for B over D? You should be looking up here and counting up all the times when B is above the D. What do you say?
28 for B.
28 for B. Anybody agree or disagree? I see some agreement. I feel good about that. Yeah, 28. How do we get that? B above D. That would be this column, which is 14, plus another 10 from this column. So that's 24, plus not these guys, but yes, these guys. B above C. So that, I said 14 and 10 and 4. That's 28. And then how many have C above D? That would be the column with the 10 plus the column with the 1. Is that right? 10 and 1 is 11. How can this be? 8 and the 1, yeah, is 9. Okay, great. Remember, they should be adding to 37. That's why I didn't like the sound of that. Yes, it's the column with the 8 has D above B, and the column with the 1 has D above B. Okay, so B versus D is B. All right? And then finally, the last one. This is a little tedious. Although I hope you agree with me, not exactly hard. You just got to work it out. C versus D. How many have C on top? I would say the first column does. The next column also. Not this one. Not this one. And yes, this one. So the first two columns plus the last one. That's 24, 25 for C. Anybody agree? And if I added it correctly, then the other one has to be 12, so that they add to 37. Or you can count it up. It's the 8 column and the 4 column. That's 12. And so C is the winner there. All right? This is all of the work which is necessary to do Condorcet's method, which is, I will leave it to you to decide. Is that easier or harder than the rank choice? Maybe a little harder? It's not, I don't really mean hard. It's just, it'll take you a few minutes longer. Maybe. All right. Anyway, what's my final answer? That was all the work here. You have to look up here and decide for yourself, is there any candidate who won in all of their matchups? Now, just looking at the results here, there's not anybody who won everything, but it's not possible to win all of them because each individual candidate doesn't even participate in most of these matchups. But anyway, anybody see one of them that wins every time? Yeah. C is the winner in every one of their matchups. A versus C, it went to C. B versus C, it went to C. And C versus D, it went to C. So, C wins all of their pairwise comparisons. And this is how you decide the winner using Condorcet's method. So, C wins with Condorcet's method. That's how we do it. All right. Any thoughts about that? Here's something to observe. I think having done this, would you agree with me that actually kind of some of these ended up being irrelevant, right? Like this A versus B actually didn't even matter because C ended up being the winner. Could I have just skipped that when I was doing the problem? I see some nods. I see some Anybody have an opinion? Like if this is on the homework, can you just like only do 3 of them? Don't do all 6? No? Why not? It would change your answer? Yeah, I'm not sure what you mean by that. I think the issue is just like when you're doing this, you don't know who's going to be the winner, and so like you could say after the fact, yeah, I didn't actually have to do this one. Okay, I guess so, but I had to do all of them in order to figure out who the Condorcet winner is anyway, right? Yeah.
Couldn't you, like, not necessarily eliminate that whole pairwise comparison, but couldn't you just not use A in the comparisons because in every column but one it's last? So it can't be the winner?
maybe. I think one thing that you can say is once you've done this one, B beats A. That means definitely A is not the winner using Condorcet's method because A did not win in this comparison. So from that point of view, once you did this one, actually you kind of don't need to compare A versus C. Like you know A is not going to be the Condorcet winner after you do this one. But actually you still don't know about B, C, and D. I think you really do have to do them all, even though in retrospect you realize that C was going to be the winner, but you had to work it out to figure that out. So in conclusion, yes, you do have to do them all. All right. Any other questions about it? Great. Let's try. I got one more example just to see what kinds of things can happen. You know, usually it goes more or less like that, and there's not a whole lot. Nothing weird is going to happen when you do this. Here's another example. So there is something, I guess, slightly interesting that can happen sometimes, which didn't happen in that example we just did. Let's imagine this is just A, B, and C. 12 people said A, B, C. 8 people said B, C, A. 7 people said C, A, B. 2 people said B, A, C. All right, and again, let's try to decide this using Condorcet's method. This, if you add up, there are 29 votes here. All right. If you have an even number of voters, sometimes you can get ties, and then you just have to say, well, like it's a tie. But with an odd number of voters, you're not going to get ties in the pairs. All right. This one's going to be easier because there's only 3 candidates, and when you have only 3 options, there's actually only 3 ways of matching them up in pairs. I can do A versus B, I can do A versus C, and I can do B versus C, and that's it. Those are the only matchups we have to worry about. But anyway, we're going to do the same old thing. In A versus B, we look at who here likes A better than B? Come on. There we go, the dot. Who likes A better than B and who likes B better than A? I see A above 12 times here, not there. Yes, there. So this is 12 and 7 and not that. That would be 19 have A on top, and I guess 10 have B on top. So A is 19, B is 10. So A is the winner in that comparison. Right? What about A versus C? The first column, 12 have A above. These guys don't, these guys don't, these guys do. So this is 12 and 2 have A on top. That's 14 for A. And B, I see 8 and... Did I do that wrong? Yes. I should have said 12 and 7 have A. What?
It's A and C.
I'm talking about A and C. Yeah. Sorry. A and C. I believe it is 14 for A, and C on top of A is 8, and 7 is 15. All right. I find it easy to get myself confused. Okay, so C wins that comparison. And finally, my pencil is acting up. Sorry. B versus C. All right, B and C. B is above C here. That's 12 and 8 and 2. So that's 22 have B above. And C, it's only here, 7. All right? And so B is the winner here. All right, that's all the work to be done. What is our answer then? Who is the candidate which wins every one of their pairwise matchups? The answer is ain't nobody who wins all of their pairwise matchups, right? Each one of them wins once and loses once. So here, no candidate wins all of the pairwise comparisons.
Can that only happen with an odd number of candidates?
No, actually, this is possible. It's possible if there were 4 candidates or any number. Yeah. No candidate wins all pairwise comparisons. So this is the major bummer about Condorcet's method. Like I said about ranked choice, there are many places in the real world where people use ranked choice in elections. There are basically no real-world elections which use Condorcet's method, and this is the reason. Sometimes there just isn't a winner with Condorcet's method. You could say in this case it's like a three-way tie, I guess. Nobody is the winner. Now, ties are technically possible with, say, the plurality system. It is possible in theory to get a tie, but that's very, very unlikely when you're using the plurality or the ranked choice. Ties are statistically possible, but in the real world, essentially, it's never going to happen. But with Condorcet's method, you can get this kind of a tie situation actually fairly easily. It's not astronomically unlikely for this to happen. So no candidate wins all pairwise comparisons. So there is no winner with the Condorcet method. So, like, as a mathematical method, this is still sensible and still interesting to talk about, but people really don't like doing this in the real world because this right here is basically an unacceptable situation in the real world. You don't want to run an election and then afterwards just say, well, nobody won. See you next year or something like that. That just doesn't, that's not good enough in the real world. Okay, so this is why I will say this very clearly. Condorcet's method doesn't always choose a winner. And for that reason, nobody uses this in important political elections in the real world. So it's not used in politics. It's not a practical system in the real world because sometimes, and actually, it's not unlikely that if you do it in the real world, you get an answer that's just like, well, nobody won. All right. Condorcet's method. All right. Any questions about that? This is why you've never heard of Condorcet's method in the real world.
Why do you have it?
Why do we even talk about it?
Yeah.
Yeah, I think it's interesting as a concept. It's not useful in the real world. But one thing that I could say about Condorcet's method is, and this is something we're gonna talk about as we go on. If there is somebody who wins using the Condorcet method, then that is a pretty strong statement in favor of that person. It means that they would have defeated any other candidate in head-to-head competitions. For example, in the Bush-Gore Nader election, if they had done the Condorcet's method, Gore would have been the winner. That means that Gore was preferred over any other individual candidate by most of the voters. Like this, that information is interesting. It doesn't mean you should use this system in the real world as in politics, but it is still an interesting way of analyzing the situation. Yeah. All right, Condorcet's method. An interesting way to do it. Doesn't really work out in the real world. I got one more method to talk about before we move on to something a little different. So that was Condorcet's method. We're really going to talk about 4 major different methods, although we'll mention a few others as we go. One more, another voting method. Unfortunately, this one is also just named after a person. This is called the Borda count. You just have to remember which one is Condorcet and which one is Borda. Those are not descriptive words, unfortunately. The Condorcet is about pairs. The Borda count, this word count is helpful, I think. Borda is just the name of some guy who came up with this voting system kind of a long time ago. I think Borda was like a French nobleman or something in the 1700s. I don't know the details off the top of my head. But anyway, the Borda count This one actually is one that I think any one of us would come up with if you were just trying to invent a voting system. The Borda count is a very sensible sounding idea. So I'll describe vaguely first, and then we'll talk about it in detail. Based on individuals' rankings, candidates get points. I think even the first day we started talking about this, I just asked, how would you think if you had to invent a system on your own? How would you think of inventing a system? And somebody suggested, can't you just like add up a bunch of points or something and then decide who got the most points? Based on rankings, the candidates get points. You add them all up to find the winner. All right, the Borda count, that word count, to me sounds like points. You're adding up a bunch of points and counting up who is the winner based on the Borda points. All right, how exactly is this done? There's this very specific way in which we do it. I will say ranking, like if I had, say, A, B, C, D in that order, how do you assign the points? The standard way to do this with the Borda count, the points go like this, 3, 2, 1, 0. All right. So when you're doing the Borda, and if you had, say, only 3 candidates, A, B, C, then the points go 2, 1, 0. You always make it so that last place gets 0 points. Last place gets 0. And then as you go up, you get 1 more point each time. So other spots accordingly. All right, if you want to be very specific about it, I could say it this way with the N candidates. The first place rank, how many points do you get if there were N candidates? Where N is like some variable or something. In this case, there were 4 candidates. The first place gets 3 points. What do you think? N minus 1 is what I would say, yeah. You want to memorize that formula? I don't know. Technically, this is a formula. I wouldn't say it's worth memorizing, but if you have 4 options, the top ranking gets 3 points. If you have 5 options, the top will get 4 points, and so on. All right, this is how we do the Borda count. Let's just do some examples. This one I would say is the most intensive in terms of calculating. You have to add up a bunch of numbers, which is kind of a pain, I guess. But it's not really hard. You just gotta keep it all straight. Let's do an example like this. Let's say one person says A, B, C, D. One person says B, A, D, C. One person says C, D, B, A. All right. You find the winner using the Borda count. So I always like to just write down my points here. When I'm doing Borda, the points go 3, 2, 1, 0. You always put 0 on the bottom and then go up. And then we add up the points. So I can just add the points. How many points does A get? Well, you have to look across the columns here. A gets 1 vote in first place here. That's 3 points. That's from the first column. Plus, A gets 1 vote in second place here. That's 2 points. So 3 from the first column, and then 2 from the middle column, and then from the last column, A gets 0 points. So I will write plus 0, which is 5. Right? Once you know what you're doing, you can probably do most of this in your head, but I'm trying to write out all the details just so that everybody can follow along. All right? So A gets a total of 5 points. And you just got to work this out for each of the options. B, what do I see? I see 2 points here, 3 points, and 1 point, right? 2 points here, 3 points here, 1 point here. So this is B gets a 2 plus a 3 plus a 1, which is 6. What do you think for C? Somebody shouted out.
1 plus 0 plus 3.
All right, 1 plus 0 plus 3. I agree. C is here and here and here. That's a 1, a 0, and a 3. So that is 4. And then finally D. I see 0, 1, and 2 for their points. So 0 and 1 and 2 is 3. And who is the winner? B is the winner. B wins using the Borda. This is how you do the Borda count. It's pretty a pretty simple idea. It seems pretty reasonable to me. You know, add up the points. It's not like I said. This is something that, given enough time, I think any one of you would have come up with this idea on your own. Yes.
T, 3 or 4?
Did I? It's 4. Yeah, thank you. 1 plus 3. Sorry, no, I wrote it wrong. It is 3. It should have been a 1, a 0, a 1, and a 2. This 3 that I wrote should have been a 2. Thank you for that. I was saying you all probably would have come up with this on your own. I would have added up the numbers wrong, but I would have come up with the idea myself. Sure, it's not a complicated idea. All right. This, by the way, the Borda is used. The Borda count is basically what they do. It's used a lot in sports type things. For example, I happen to be fairly skilled in Mario Kart, and maybe you know, in Mario Kart, after you have like 4 races in a row, and after each race you get a certain number of points based on which position you finished in, and then they add up the points to see who gets the trophy at the end. Right? It's basically doing the Borda, right? In Mario Kart, they don't assign the points in this way. Like last place, you still get 1 point. That's because Nintendo wants you to feel good, even if you're not a pro gamer. And they give you some kind of bonus for first place. Is like a few points more than second place. But anyway, that's basically how it works. There are similar systems. Like I believe I don't know much about this, but I believe the World Cup uses some kind of points system. Anybody know this? Something like if you win a game, you get 3 points. If you tie, you get 1. Am I right about that? None of you are into the World Cup. I believe that's how they do it. That is basically like the Borda, where you have a bunch of individual, like each match you would think of as if people were voting, and then winning each individual vote gets you a certain number of points, and then they add up all the points at the end. Why don't they do just like elimination every time, which would be maybe more like the ranked choice, where you kick people out? The World Cup has some kind of elimination thing at the end, I guess. But anyway, these systems involving adding up points are very common in the real world. It's not used all that much in actual politics for reasons which we're going to discuss, but it's not a bad system, really. I mean, there's no obvious deficiencies to this system using it in politics. Let's try just another example here. Now, this example was actually extra easy because of all these ones here. If these are not ones, the mathematics that you have to do, the adding gets slightly more complicated. It's not so bad, but you do have to think a little bit differently. So let's say, here's another example. 3 people said A, B, C. 2 people said B, C, A. All right? And I'm going to add up. This is one of the only times this whole semester, actually, but you have to, in this case, not only add, but you also have to multiply here. Because how many points does A get? Well, A in this position gets 2 points, but there were 3 people who voted in that way. All right, so in this case, A is actually getting 6 points from this column. That is 2 points for their position times 3 people who cast their vote in that way. So I'm going to write this as 3 times 2 from the first column, plus, how many points from the second column? Well, 0. So actually, it doesn't really matter. 2 people gave them 0 points. I will write it just for clarity as 2 times 0. All right. Each time you have to multiply the number at the top of the column times the point value for that location. So this one here would be 6. B gets, here I have 1 point in this column, but there are 3 people, so that's actually 3 times 1 plus B in this location, 2 points times 2 votes, so that's 2 times 2. And this would be 3 and 4 is 7. All right? And then finally C, 0 points here, 1 point here times 2. So this is 3 times 0 plus 2 times 1, which is 2. And B wins. All right? So when you're doing the Borda, you have to multiply also. All right? But not so taxing, right? I thought it might be fun. Let's try to look at the Bush-Gore-Nader election and see what would happen in there if we use Borda instead of, well, we've done it with plurality and ranked choice. Let's look at the Bush-Gore-Nader. I will remind you of the numbers. 2.9 million say Bush-Gore-Nader. No, Bush-Gore-Nader. 2.9 million people say Gore-Bush-Nader. Remember, I'm being charitable to Bush in that measurement. And then 0.1 million said Nader, Gore, Bush. All right. What do you get with the Borda count? Let's see if we can add up the points. The points here go. It's always 0 points for last place, and then it goes up from there. So 0, 1, 2 for the points. All right, let's do it. You don't have to really think too hard. You just got to make sure you get it straight about the multiplying. So in the first column, Bush is getting 2 points times 2.9 million for the column heading. That's 2.9 million votes gave them 2 points each. So this is going to be 2.9 times 2. All right, plus. You always multiply the number up top times the point value. In the middle column, the points is 1 point, 2.9 million times. So this is 2.9 times 1. Plus the final column, 0 points, 0.1 times that doesn't really matter, but 0.1 times 0. All right? And when we add these up, you got to multiply and add. I did this. I got 8.7. This, of course, is million Borda points. All right. By the way, when it comes to doing this Borda stuff on the homework, I would expect you to just use a calculator if you want to. On our quizzes, I will make the numbers such that you don't need a calculator. Like this one here, I would expect you to be able to do this kind of stuff without a calculator. I hope that doesn't seem too taxing. As you know, I am likely to mess it up myself, even when it is easy. So I'm not. If you just mess it up by accident, I'm not gonna screw you with the grade. If you can set this up properly, that's what I care about. All right. Next, Gore. What do we got? Gore in the first column gets 1 point times 2 points. So this is 2.9 times 1 from the first column. The next column, they're getting 2 points. So 2.9 times 2 for the middle column. And in the last column, they're getting 1 point. It's 0.1 times 1. And this, when you add it up on your calculator, you get 8.8 million Borda points. All right? These numbers are actually the same as Bush and Gore. They're just in a different order. But here, Bush got 0, whereas Gore got 0.1 extra. So Gore finishes with 0.1 million extra points. So Gore is going to win. Actually, we might as well add them up for Nader. Anyone think Nader might pull this one off? No, it's not going to happen. There's no universe in which Nader was going to win this election. Add them up. 0 points here, 0 points here. So this is 2.9 times 0 plus 2.9 times 0 plus a big win in the third column, 0.1 times 2. That all adds up to 0.2 million Borda points. All right? So Nader was not the winner. Gore is the winner. Gore wins using the Borda count in this election.
What against General Motors?
Yeah, Nader is not a total loser in life. Nader had several successes in life. He wrote a book about, what was that car?
Yeah.
Was it the Pinto?
It could have
He wrote a book about a car. There was like a specific car which would blow up if you get into like a minor fender bender. It would explode because like the fuel tank was right next to one of the bumpers or something. Nader shut that whole thing down though. That was his big victory early on in his career. All right, so Gore would win this election using the Borda count. I read an interesting article once about the Borda count. Somebody did an analysis of the presidential election, I believe the first presidential election of Abraham Lincoln. Apparently there is good evidence that if the Borda count had been used in that election, then Abraham Lincoln would not have become the president. It would have changed the results, which probably would have been a big deal in American history. All right. Let's just do one more example. I wanted to do, again, one last time, the big example on the paper. We've done it 3 times already, right? The plurality, the rank choice, and the Condorcet. Let's do it just one more time with the Borda. Maybe I will copy. I had this one right here, these numbers. Oh. I want to do this with the Borda. All right, let's see if we can do it. So the points always start 0 at the bottom. 0, 1, 2, 3 in this case. And then we just, adding and multiplying, right? This one I would suggest you use a calculator if you really want to do this. I worked out the numbers ahead of time. In the first column, for A, 14 people give A 3 points in the first column, plus, actually, all other columns are zeros for A. But if I wanted to write it all out, it's 10 times 0, plus 8 times 0, plus 4 times 0, plus 1 times 0, right? And this, when I put this in my calculator, 14 times 3, I got 42 for A. All right. How about B? A similar thing. B gets 2 points in the first column, so that's 14 times 2, plus 2 points in the second column, that's 10 times 2, plus 1 point in the third column is 8 times 1, plus 3 points in the fourth column. I'm looking at B here, 4 times 3, and then here 1 times 1 is whatever that is. This you can do in your calculator. Make sure, by the way, if you're using a calculator for this, you do the proper order of operations. You have to do all those multiplications first and then add everything together. If you're just using like your simple phone calculator app, if you just type it in exactly this order, you'll get the wrong answer. You have to do all the multiplications first. So I would, if I were working this out, I'd go, that's 28 plus 20 plus 8 plus 12 plus 1. This is just a little point about using your calculator. And then those you add up. Anyway, you get 69 if you did that. All right? B gets 69 points. All right, let's just work them through here. I hope this isn't too boring. It's not particularly fascinating. You just have to add up the numbers. So this is going to be, for C, 14 times 1 in the first column, plus 3 points in the second column. So that's 10 times 3 in the second column, plus 8 times 2 for the middle column, 2 points. Plus the column with a 4 up top, they're getting 3 points. What? No, sorry. 1 point. It's here. I'm looking at C. 4 times 1 for that column. Plus C is on top in the last column. 1 times 3. I think I did that right. Add all of those up. I did this ahead of time, and I got 67. And then finally, we have one more. I'm going to move this up so I don't have to scroll away. D. All right, same old thing. Looks like 0 points in the first column. 14 times 0 plus 10 times 1 point in the second column, plus 8 times 3 points in the next column, and then 2 points from each of these last two. So that's going to be 4 times 2 plus 1 times 2. And I add these all up, and I got 44. And so the winner is here, B. All right. that's how we do the Borda. This is about as complicated as these are going to get. And like I said, on your homework or something, I would expect you to use a calculator. In class, this I would probably say this is beyond what I would expect you to do in class. I'm sure you could all do it, but it would take a while and you'd probably mess it up. At least I would. I don't mean to judge you all. All right. I have no reason to really make you multiply and add a bunch of numbers on a quiz or something. So if there are Borda questions, I mean there will be Borda questions, but they'll be simpler than that. All right. A little summary about this example on the handout here. So in this example, this is interesting, I think. If you just look at the four methods we've talked about so far, plurality, the winner was A. Borda, that's the one we just did. The winner, sorry, I'm messy here. The winner with Borda was B. The ranked choice, I believe the winner was D. And the Condorcet, which we did, 20 minutes ago, the winner was C. All right? The moral of the story is you can get different answers depending on which system you use. I mean, we all know that already, I think. But these four different systems, none of them is obviously a bad idea, although we've seen that the Condorcet method sometimes doesn't give you a winner, and so for that reason it's not very practical. But it's not mathematically a bad idea, it's just sometimes you don't get an answer. But anyway, the big moral of the story is the system you use can make a big difference, right? And different reasonable systems can give different reasonable answers. And looking at this particular election with four alternatives and four different outcomes, who's to say which of those is like the right answer? My response, if you ask me, oh, well, it's different each time, but like which one is the real true winner? I would say, well, there's no such thing as like the real true winner. These are all mathematical calculations that we do, and you're doing different processes, so you get different answers. There's no real good reason to expect to get the same answer every time. All right? When you see different answers based on different systems, it does not mean, for instance, that the Borda is like a rigged system because I got a different answer. No, it's a different system, so yes, you get a different answer. There are, you can talk politics about which one you think is more democratic, although I would say, at least on a surface level, they're all democratic. They all measure people's votes, right? Who's to say which one is better and which one is worse? All right. Actually, I do want to talk about how could we measure which one is better and which one is worse. This is our next major topic. So I said on the first day, I don't know if you remember, I said we're going to talk first of all about different methods by which you could decide the winner, and then we're also going to talk about how could you evaluate one method over another and see which one. Is there some kind of way to measure if any one of these is better than the other ones or worse? Other than the obvious fact that the Condorcet doesn't always choose the winner. I think that's a basic fact which makes Condorcet unusable in important elections in the real world. But besides that, are there other ways that we can try to measure if these are good or not? All right. What I would like to do, though, we got 15 minutes, and I haven't asked you to try anything on your own. I want you all to try, just to sort of close the loop on this, and this will be the last time we do this. I want you to try the big best movie ever election, and I would like to decide that one with the Condorcet and the Borda. Hopefully you have that paper. If not, I have it on the screen here. So we have done this already using the plurality. When we did the plurality, Star Wars was the winner, and when we did ranked choice, Star Wars was also the winner. What about, I want to see what happens when we do the Condorcet and what happens when we do the Borda. All right. We have about 15 minutes. Let's see what you can do. I'm going to walk around and see how you're doing. When you do the Borda, you're going to want to use a calculator. So, use your phone calculator. It's probably good enough. Or if you have a fancy calculator. If you have a fancy calculator, I suggest take that sucker to eBay. Get some money for that. And then download a 99-cent calculator app that can do all the same stuff. It's a scam, I tell you. That's a rigged system. The TI-80, whatever it is, costs you $100 for something far less capable than your phone. All right, I'm going to walk around and see what you think about all these. I hope you remember how to do the Condorcet. Make sure you get all 6 possible comparisons if you're doing the Condorcet. I'm trying to help you out a little. I believe there are 29 total voters here. So in a 1-to-1 matchup, can anybody say how many votes do you need to win? In each of the, out of 29 total? Yeah, I think 15 gets you a win, right? So you need 15 to win. This way you really only have to count up one of them. If they get 15 or more, then they win. Remember what to do. Yeah, you got to kind of look carefully. Wait for a minute. What's else? Okay. I hope we got H for the winner in the first one. I counted 18 votes for H. 11 for L. See if you agree.
Yeah, I don't know.
Make sure you pay attention to those.
Yeah.
Yeah, I'm gonna give you 2 more minutes. I know this is gonna take a while, but we gotta leave at 12:15 anyway, so I'll give you a couple more minutes and then I'll try and get it all out in 5 minutes.
I was counting the first place when it said all of them, so I
Still good? All right, can we talk about these? I know I don't think anybody's done yet, but this just because we got to go in 5 minutes. When I did this, I got 18 to 11 in that first comparison. H versus S, I got 19 for S and 10 for H. Anybody agree with that? Yes. All right. So Star Wars is the winner there. What about H versus T? Maybe can somebody say? I know some people got that far. What'd you get for that? Yeah.
I got 19 for H and 10 for T.
19 and 10. Anybody agree?
Yeah.
Yes. Okay. I'm going with it then. Great. What can we say so far? I don't know. I guess it's not going to be H because H lost this one. It's not going to be T because T lost this one. It's not going to be L because L lost this one. You can try to avoid finishing. Sometimes you can finish early. It might be S though that takes it all. How about this one? L versus S. Did anybody get that far? What'd you get?
L5, S24.
All right. Anybody agree or disagree?
Yeah.
Agree. Okay. S gets 24. I don't expect that you all were able to do all of this that fast. And like I've said many times before, I don't care if you can do these fast or slow, just that you know how to do it. How about L and T? What'd you get?
L 14,
14 and 15? That sound good? Yeah? All right. So T is the winner there. It looks like Star Wars might actually pull it off. What about S versus T? Did anybody get that one? Yeah?
19 S, 10 T.
S 19, T 10. Anyone disagree? No. All right. I'm going to go with it. So assuming those are all correct, it's easy to mess them up. Star Wars is the winner, right? Star Wars wins every time in any of those pairs which involve Star Wars. All right? Don't pack them up yet. I want to do the Borda. So S wins with the Condorcet. This is pretty serious. Star Wars winning the Condorcet is a very strong signal. You all see the new Star Wars trailers this past week? Pretty epic stuff. I'm talking about Yaddle. You guys know Yaddle? Yaddle was the female Yoda who was in The Phantom Menace and did nothing and never appeared in anything again. She's back. Yaddle. I'm hyped for Yaddle. All right, let's see if we can do the Borda. Okay, this is going to look like a whole bunch of adding a bunch of nonsense. Actually, I didn't. Maybe we'll just start next time with this. All right, it's kind of annoying. It's a bunch of adding.